An engine is a machine that converts stored chemical energy into motion, or, in fancy terms, kinetic energy. How does this work? The basic clue is that a gas expands when we heat it up. In the engine, heating up the gas in the cylinder is achieved by burning the fuel. When the fuel ignites, the air inside the cylinder expands and pushes the piston down. And here we have it, motion. There are basically two different ways to achieve this energy conversion in an engine: the 4-stroke and the 2-stroke cycle. In outboard engines, we find both principles. Older outboard engines are mostly constructed as 2-stroke engines, while newer designs tend to use the 4-stroke cycle. Let us start with the 4-stroke cycle. First up, we have the intake stroke. Imagine the engine taking a deep breath. The piston moves down, and the intake valve opens up. It's like opening a door to let air and fuel into the engine's chamber. This mix is the secret recipe for power. Next, we're at the compression stroke. Here, the engine is compressing the air-fuel mixture, squeezing it into a tiny space. Think of it like packing a spring. It's all about building up power. The intake valve closes, the piston moves up, and the mix is compressed, getting ready for a big bang. Now, it's showtime with the combustion stroke. This is where the magic happens. The compressed mixture is ignited by a spark plug. Kaboom! This combustion pushes the piston down with great force, turning energy into motion. It's like a mini rocket launch inside the engine. And finally, we wrap up with the exhaust stroke. After the party, it's time to clean up. The exhaust valve opens, the piston moves up again, pushing the exhaust gases out through the exhaust valve. It's like exhaling after a good workout, getting ready for the next round. And there you have it, the fantastic 4-stroke cycle. Each stroke plays its part in a perfectly choreographed dance, powering your boat through the water. Now that we've explored the rhythmic and powerful world of the 4-stroke cycle, let's shift gears and dive into something a bit different. Enter the 2-stroke cycle, a more compact engine design. While the 4-stroke is like a methodical dance of power, the 2-stroke is akin to a sprinter, delivering energy in quick, efficient bursts. Imagine the 2-stroke cycle as a high-speed dance of fuel, air, and fire. First, we have the combined intake and compression stroke. Here's how it goes. As the piston moves up, it compresses the air-fuel mixture. Think of it as squeezing a balloon. Simultaneously, on the other side of the piston, new fuel and air are getting ready to enter the party. It's like prepping the next fireworks while the current one is still dazzling. Next, the action-packed phase, the combustion and exhaust stroke. This is where our engine really shines. When the piston reaches the top, a spark plug ignites the compressed mixture. Boom! The combustion drives the piston down, and this is where we get the power to zoom through the waters. But wait, there's more. As the piston moves down, it also opens up the exhaust port. It's like pushing down on a pump. The old air is whooshed out, making room for fresh fuel and air to start the next cycle. In just 2 strokes up and down, our engine does it all: compression, power, exhaust, and intake. After covering the engine cycles, it's important to understand some key components of an engine. Here's an explanation of valves, spark plug, camshaft, connecting rod, and crankshaft in simple terms. Imagine valves as tiny doors in the engine. There are 2 main types: intake valves and exhaust valves. The intake valves open to let the air-fuel mixture into the engine cylinders, the rooms where combustion happens. After the mixture burns, the exhaust valves open to let out the waste gases. They walk in a precise rhythm, opening and closing at just the right times during the engine cycle. The spark plug is like a small lightning bolt inside the engine. For engines that need them, like petrol engines, it creates a spark that ignites the air-fuel mixture in the cylinder. This spark is what causes the explosion that gives the engine its power. Without the spark plug, the fuel wouldn't burn, and the engine wouldn't turn. Think of the camshaft as the conductor of an orchestra, controlling the timing of the valves. It's a long rod with several lobes, or cams, that rotate and push against the valves, opening and closing them at the right time. The camshaft's rotation is synchronized with the engine's operation to ensure everything runs smoothly. The connecting rod is like the arm of the engine. One end is connected to the piston, a flat piece that moves up and down in the cylinder, and the other end is connected to the crankshaft. When the fuel burns and the piston moves down, the connecting rod transfers this movement to the crankshaft. The crankshaft is the backbone of the engine's movement. It's a long shaft with several offset sections. As the pistons move up and down, the connecting rods push on these offset sections, turning the up and down motion into a circular motion. This circular motion is what ultimately turns the propeller of the boat and moves it through the water. In essence, these parts work together in a coordinated dance. The valves control the fuel and airflow, the spark plug ignites the mixture, the camshaft ensures everything is timed perfectly, the connecting rod transfers the motion, and the crankshaft turns this motion into the power that drives the boat. Each component is vital for the smooth operation of an engine.